Hello guys. I welcome everyone to the stream. Sorry for the delay, it was just because of some internet issues. So today we are gonna discuss about the recent today's Leetcode biweekly contest, which is contest number 164, biweekly Leetcode. So there were 4 questions, and today again, as recent Leetcode trend, they are giving the second question a little more complicated than earlier days. So how did all of your contests go today? Okay, we'll go to the question. First question. Okay, so we'll go to our first question, which is find the least frequent digit. Okay, find the least frequent digit. It says, given an integer n, find the digit that occurs least frequently in its decimal representation. If multiple digits have same frequency, choose the smallest digit. The frequency of digit, return the chosen digit as an integer. The frequency of digit x in the number of times it appears in the decimal representation of n. So they have given that number is given, and we have to find a digit which will appear the least number of times in the decimal representation. So this is our question. We'll see the first example. N is equal to 1553322. So 55 appeared twice, 33 appeared twice, 22 appears twice. So and 1 appear only once. Now so we are gonna get the output as 1. Now n is equal to 7233445111. Here 7, 2 and 5, these 3 digits appear once. Okay, I'll quickly shift to my writing screen. What is the question number? Find the least frequent digit. First, okay. Biweekly 164. Oh, it's already there. Okay, so the first question is least frequent digit. Least frequent digit. Okay, so for example, if we are given a number 1436312, if this is a given number, first we have to check which is the least occurring number. That is 2, 4, 6, and 1 is appearing 2 times, and then 3 is appearing 2 times. And in 2, 4, 6, since 3 numbers are appearing, we need to take the smallest number, which is 2. Our output will be 2. This is what is basically a question given. Again, a very easy question. We'll see the intuition for this question. Anyone in the chat? Intuition. Simple, guys. What we'll do here, we have to find digit which appears least. Find least appearing digit. So what we'll do first, what we'll be doing first, convert to string. So we can easily iterate. Why? To easily iterate easily over digits. Done. And then count frequency and count frequency. This is a easy thing. That's all. That is basically, and return that thing. That is the only thing. This is straightforward what we are doing here. Simply frequency count plus minimum search, min search. That's all we are doing. I'll go to the approach. The approach for this question. First, convert. Okay. So, convert the integer n to string. Why we are doing this? It's easy to iterate over the digits in string. After this, what I'll do, just give me a second. Hello, sorry for the disturbance, guys. Now what we'll do, we'll create a frequency array. Create frequency array that counts 10, which is initialized with 0. This is because this 10 is because we have digits from 0 to 9 and initialize with 0. Initialize with 0. Done. In the next step, just update this. Find minimum non-zero frequency. Minimum non-zero frequency. We'll simply ignore the digits that are not appearing. And now finally what we'll do, we'll iterate over digits. We'll iterate over digits 0 to 9 in increasing order. In increasing order. And what we'll do after this? Return digit with min frequency. And return digit with min frequency. So by this we ensure that smallest digit is picked. Smallest is picked if we have equal frequencies, same frequencies, whatever it is, equal or same frequencies. Done. So this is what is basically our what do you say, the approach which we are gonna follow. I'll write the pseudocode. I'm not gonna give the codes. I'll be writing the pseudocode so you guys can code it yourself. Pseudocode. So yeah, in this inbuilt class solution and the next line, the function def whatever the fn, the function it's given. Next you take a string, s is equal to, convert it to string, then counts, initialize it initialize the count array, and after this our loop, what, for character in string, increment counts. What will do? Counts int character plus equal to 1 incremented by 1 basically. Now take one more called min frequency, which is equal to minimum of C from counts, basically minimum of character from counts. Counts is this. And this is only if C is greater than 0, because we need non-zero. This is done. Now again we'll run one more for loop for D in range 10. We'll put a condition if counts of D is equal to minimum frequency. What we'll do, we'll return D. That's all basically. Return D. That is basically our code. I hope everyone is clear. You can also use it completely using modulo operator and integer division, numeric approach, but due to time shortage I'm not gonna tell you guys that in detail. But if anyone in the chat wants that, I'm gonna tell it. If anyone in the chat wants, please let me know. I'll tell that to you guys. This is all about this question. Now the time complexity, space complexity, time complexity. So counting the digit, D is the number of digits. So count the digits. It will take O of D, and then finding minimum frequency is 10. Find minimum frequency. This is O of 10. So our total time complex, and scanning digits again. Scan digits. For this also it's again O of 10. Now what is our total time complexity? It is O of D plus 10, which is equal to O of D, and this is time efficient again. So the final time complexity is equal to O of D, where D is the number of digits. Now space complexity, we have not used anything except the frequency array and a few variables. Array size is 10, so it will be O of 10, and then a few extra space, but here for D, which is number of digits, but here D lesser than or equal to 10, therefore negligible. And O of 10 means we can reduce it, it is nothing but O of 1, so the space complexity is equal to O of 1. Done. Anyone has any doubts? Anyone in the chat any doubts, guys? If anyone in the chat has any doubts, please let me know, or else we'll go to the second question. We'll go to the second question. First is done. 2-letter card game. You are given with a deck of cards represented by a string array cards. Each card displays two lowercase letters. You are also given a letter X. You play a game with the following rules. Start with 0 points. On each turn, you must find two compatible cards from the deck that both contain the letter X in any position. Remove the pair of cards and earn 1 point. The game ends when you can no longer find a pair of compatible cards. Return the maximum number of points you can gain with optimal play. Two cards are compatible if strings differ by exactly one position. So okay, fine. So what are they saying here? Pairs of strings are given. Okay, pairs of strings. What is this? Deck game, card game. Okay, so the second question, what is the title of the question? Two-letter card game. Second question is two-letter card game. So if basically it is compatible if, for example, let me take XY, YZ, and then ZY. There's one thing, and I'll take the target as, or X is equal to, let me take Y. So here XY and YZ, XY and YZ, they have exactly one difference of 1. Hence these two are compatible. XY, YZ, these two are compatible. And ZY and YZ, do they have any difference? No difference. Since no difference, the total maximum number of pairs is equal to 1 plus 1 plus 0. So hence it is 2. The output we will be getting for this is equal to 2. Now this is our question. Quickly going on to our intuition. What is our intuition for this question? Intuition. So we need to maximize number of pairs we need to max the pairs, max pairs where pairs we can form, basically form where we'll have conditions for this. Each card has has a letter X in it. Two cards compatible if difference equal to 1. That's all. So what we will do, what we have to do for this, so what am I gonna do is, we'll group the cards based on the structure, and we'll group it with relative to X. Group cards with respect to X based on structure. Okay, that's all. That's the first step. Next, what I'll do, I'll count the possible groups, basically. Count possible compatible groups within or between groups. Wait, give me a second. Let me take it as compatible pairs. Compatible pairs within group or different group. I mean, or between the groups. Then finally what I'll do is I'll balance the pairings with other cards. I'll balance the pairings of XX card with other cards optimally. This is what they have asked us to do basically. Now how am I gonna do this? A bit tricky question, but yeah, solvable. What is this? We'll go to our approach. Okay. So how are we gonna solve this question? Anyone in the chat, guys? How can we solve this question? Anyone in the chat, how can we solve this? Okay, fine, I'll answer it myself then. No one in the chat is responding. The first step, what is our first step? We'll pre-process the cards. Pre-process cards. How am I gonna do? Count how many times each card. Count appearance of cards first, then partition into categories, part into category, okay, the first one there was one slight mistake. This is YY, and then the output is 2 here. This is not ZY. There is a difference of 1, there is a difference of 1. YY. That's all. I just made a small mistake. So with this, I'll continue. We'll partition it. We'll make 3 categories here. First one is XX. Both are X. Both card character equal to X. And second one, XA. X first position, and A next. A is any given number. Second character, basically it's not X. A not equal to X, that's all basically. Third one, BX. X second position, and B first. here b is not equal to x, that's all. B is not x basically. And then we'll ignore the cards. Finally ignore without x. Ignore without x. Done. We'll be ignoring the cards without x basically. Now in our second step, what we'll do? Second step, we'll store midway input. Store midway input. After this, why are we doing this? This will save the original deck, and also this will save the chosen letter basically. That's why we'll store it. And then in our third step, what we'll do? Third step, what are we gonna do? We'll count compatible groups. How will we doing? For XA group, first we'll take XA group. 2 cards compatible. What is the condition? If max internal pairs, if they have different A values, only if A value differ, we'll make a small formula kind of thing for this. What we'll do is, we'll take max internal pairs formula here. Max internal pairs formula. What we'll do, this is equal to minimum of total by 2 comma total minus max part. And then similarly we'll do for same for BX group. And then we'll add them as internal max total or something, internal max total or internal total something, whatever you want, add it as that. And in our fourth step, what we'll do? In our fourth step, we'll pair XX cards. With what we can pair XX cards? With XA or BX cards we can pair. So here what I'll do, I'll take we'll take one more variable r. R is equal to total 0 plus total 1. What is this? This is non-XX cards. Okay. So C, I'll take one more variable C, which will count the XX cards. Count XX cards basically. Now here what are the cases we have? We'll get some cases here. If we have C greater than or equal to R, then every non-X card pairs. Result will be R. This is if. Next, if our internal max total, whatever it was, if that is equal to 0, then what will be there? Only possible pair is possible to pair XX with what? r is equal to minimum of c comma r. Done. Next condition, third condition, and the final condition. What is it? If not, we'll distribute, else distribute internal pairs and XX pairs to maximize result, to max the result. Done. Then our final step, optimize the answer. Optimize the answer. So what we'll do is, possible values, we'll take it as k. K will be number of internal pairs formed. Let it be number of internal pairs formed. I'll take total points. What will be my formula here? K plus minimum of c comma r minus 2k. Done. With this, I'll go to the pseudo code quickly. This has a little bit lengthy code, but yeah, it's fine. Pseudo code, whatever class, and then different function, take it whatever it is, then counter CNT, counter of what? Cards. Now we have three cases, right? Count 0, count 1, and count XX. Count 0, count 1, count XX. Counter again, counter. Okay, I'll write counter only. Counter, counter 0. Just a second, guys. Well, guys, we'll go on quickly. After this, we'll run a loop. We'll run a for loop for S and C in count dot items. If not, if X is not in, yes, we'll just continue it. Then if, we'll run the three condition, if, else if condition 1, I have told condition 1 and condition 2 and third condition, else finally the third condition. Condition 3, what are those? I have told you guys already, which is condition 1, 2, 3. Okay, here we have, this is condition 1, condition 2, condition 3. If, elif or else if and else. This is what exactly we are writing here. After that, total 0, total 0, total 1. This is sum of all those count 0 values. This is also sum of count 1, count 0. Then the midway input, store midway input, then I'll call another function. Here what I'll do is I'll take max part and I'll maximize the part values. Max part values, max of part values, part dot values. Return, I'll return what? Minimum of total by 2, comma total minus max part. I had given this formula, minimum of internal formula. This is that formula. Now we'll compute, for computing internal pairs, we'll compute the internal pairs. Pair 0, pair 1, pair 0, pairs 1, and internal pair, internal total max. After that, what I'll do, I'll take R and C. I've told what is R and what is C. R equal to total 1 plus, okay, total 0 plus total 1. C is equal to count of XX. XX is both cards. Now we'll run our if condition, which is C greater than or equal to R. Rest all I have told what to do. Return R. Now one more if case. Internal total max. What I'll do, return minimum of C comma R. That's all. T is equal to, what is our formula? R minus C divided by 2. Now I'll compare it with K. For K, we'll run one more loop. For K in cand, in whatever candidate I'll take. Before this, I'll take one more candidate. I'm not writing it fully. Candidates equal to 0 comma into internal total max comma t plus 1. I'll run on this. Now I'll take the final answer, putting all comparison. If k greater than or equal to 0, lesser than or equal to internal total max, what is the answer? Answer is equal to max of answer comma k plus minimum of C comma R. I'll just write it in the next line. Minimum of C comma R minus 2 into K, and I'll return answer. For both of the next two, I won't be providing you guys the pseudocode. You have to find it yourself. I'll just approach for the third and the fourth question. Now the time complexity of this, order of n. This is for counting and partitioning. And then rest all is O of 1. So overall time complexity is equal to O of n. Done. Now the space complexity. Again, we are using counter, which is hash maps. In the worst case, it's gonna use O of n. Hash map worst case. Worst case. Done. Now I'll go to the third question quickly. Twisted mirror path count. Given m cross in binary grid, when grid ij equal to 0 represent empty cell and ij equal to 1 represent mirror. A robot starts at top left of the grid. Guys, I'll be explaining the codes in 2 minutes. We'll take a small break for 5 to 10 minutes. I'll come back after that and we'll just continue this thing. I hope it's clear for everyone. Sorry for the delay, guys. We'll just continue it. Twisted mirror path. I was reading it. M cross in binary grid. I'll just directly explain up to this part. Up to this part, I'll just explain it. Binary twisted mirror. Third question. Twisted mirror. Twisted mirror. So what if this is a grid, binary grid? I'll draw 4 cross 4. Give me a second. I'll simply draw it with 2 cross 2 and explain. If it's a binary grid, 1 0 0 1, what it says, 0 means no value and 1 means a mirror, right? That's what they say. Yeah. If grid ij, okay, I have to put one more bracket, it's fine, understand it, equal to 1, if grid ij equal to 0, fine, grid ij equal to 0, two conditions. This is mirror, this is empty. That's what they have given. Now, quickly going on. A robot starts at top left corner of the grid 0 0 and wants to reach bottom right corner. It can move only right or down. If robot attempts to move on a mirror cell, it is reflected before entering that cell. If it tries to move right into mirror, it's turned down and moved to cell directly below the mirror. If it tries to move down into the mirror, it is turned right and moved into the cell directly to the right of the mirror. So what they say is, what exactly are they saying here? Let me read the question, that part. If it tries to move right to mirror, okay, I'll put one more. I'll put a 3x3 itself. It will be better. Okay. Oh yeah. Now I'll put it like this: 0 1 0 0 0 1. I'll keep 1 0 0. Fine. Now what are they saying here? If robot tries to move to right, it tries to move to right into a mirror. So this is right into a mirror from 0 to 1. In this case, what will happen? It is turned down and directly move to the cell. It won't go here then. It will directly come here. Okay. It will directly come below that. And if it tries, there is one more. If it tries to move down into a mirror, for example, if it tries to move down into a mirror here, this. Okay, give me a second. I'll change the colors. This is our first case. This is my first case. What does they say here? If the robot tries to move into the mirror, it will directly be shifted down. And if it tries to move to the down part, no, the next one. If it tries to move down, here what will happen? When it tries to move down, it will be moved directly to the right of the mirror. Okay. If this reflection would cause the robot to move outside grid. Okay, if in case, for example, I'll come. Okay, fine. Consider this is moving here. Okay, and okay, I'll change it a bit. I'll consider this is 1. Okay, in that case, what is gonna happen here? If this starts to move here, then it comes down, right? But there is nothing in the downside here. There is nothing here. Empty. It's coming out of boundary. Out of boundary. In this case, we will consider it as invalid path. Done. That's all is this thing. Return the number of paths from, okay, to reach from here to here. I'll again change the color. To reach from here to here, which is 0, 0, 0, 0 to m minus 1, n minus 1. We have to return the unique valid ways. That's all. Unique valid ways. This can have many ways. So what we'll do is, we'll return it as 10 power 9 plus 7 mod of 10. Okay, modulo of this number. Modulo, which is basically answer modulus of this number. There's a very large prime number which we'll be using. You all are knowing it. Done. I'll take one small example. I'll take one more grid. This time what I'll take, change the color first. Let me take a grid. 3x3 again I'll take. This time I'll take, what was the earlier one I took? 0 1 0 0 0 1. Without checking, I took the same as given in the example. It was fine. Now I'll change it. I'll now also again. Fine, I'll take a 2 cross 2 this time. 2 cross 2. This time I'll take all as zeros, okay? All the values are zeros I'll take. Now, what are the valid ways for this? We have to reach what? 0, 0 to 1, 1. Correct? So, first what it will go? First possible way. It will go to 0, 1, 0, 0 to 0, 1 to 1, 1. And then our second way is 0, 0 to 1, 0 to 1, 1. There's only two ways. So our output is equal to two ways. This is our grid. This is done. Now I'll quickly go to intuition of this. Very clearly I have explained the question, so I'll be moving very fast. Intuition part. Now we are asked to find unique valid paths. Now we are asked to find unique path. So for that what I'll do is basically 0, 0 to m minus 1, n minus 1. Done. Where mirrors will reflect the movement. Mirror reflects movement. Done. And out of bound means invalid. Out of bound, invalid. And this robot, this reflection happens until out of bound. Reflection, mirror reflection, this thing happens till out of bound. Out of bound, or it lands on a non-mirror cell, or land on non-mirror cell. Done. That's what is our intuition basically. This is nothing but it is just variation of, you might have already solved unique paths. There's a question in Leetcode. It is a same question of that. It is just modified a little bit, that's all. There you can't step on the obstacles if I remember it properly. And here you have mirrors and little bit of twisted, that's all. Little bit of twisting the question, which is Leetcode's unique paths 1 and 2. It is like, I guess it's in the order, I'm not sure. Please check it out. Now, after intuition, what I'll do, I'll go to my approach. First thing, we have to simulate the reflection. Reflection simulation. What I'll do, I'm given starting cell and direction. Direction is 0 right, 1 down. Will simulate reflection, simulate until what? The two conditions I said. Out of bound. Out of bound means return none. Land on non-mirror. Return coordinates. return coordinates. Done. There's my first step. We'll just use LRU cache to avoid, if you guys want, use LRU cache to avoid recomputation. Done. Now, in our second step, this is a DP question. Since I said unique path, everyone are very well aware of it. DP question. Now I'll set the DP for it. DP setting, DP setup, whatever you guys call it. DP formation, DP setup. Now, DP of ij 2D DP is equal to number of ways to reach ij, I comma j. Okay. Now what I'll do, I'll take dp of 0 comma 0 is equal to 1. This is my starting point. I'll start with this. Now what I'll do here, I'll put a for statement for each cell I comma j. What I'll do is skip if mirror, else will propagate to the next reflected part. Propagate to next path, next cell basically, not next path, sorry, next cell in both direction. Now after this, I have to very importantly use, what should I use? Modulo of 10 power 9 plus 7, a large prime number basically. And then in our third step, what I'll do, I'll return my final answer. Return dp of m minus 1 and n minus 1. This is number of valid paths to destination. That's all. I said I'm not gonna give you guys the pseudocode, so you guys should write the pseudocode yourself. I have explained the question very clearly. Now, what I'll do now is I'll go to the time complex directly. I and j has two calls, and next endpoint, which is what is this next endpoint? It is next cell. Next cell is memoized, so computed once. Now worst case simulation of worst case, traversing O of m plus n mirrors, but since caching is there, this total work, because of cache, this will bring it down to O of m into n. Now because of cache, it will be computed once, bringing the time complexity to O of m into n. So the overall time complexity is O of 2, the first one, plus O of 1 plus O of m into n. The time complexity is equal to O of m into n. That's clear, I guess. And space complexity, very easy, 2D dp table. dp of ij, which is basically consider I as m, j as n. This will be O of m into n. Space complexity is equal to order of m into n. Done. Again, I am telling, similar to unique path. Unique path and unique path 2. Leetcode questions. Leetcode questions. So if you guys want, solve them also. Classic DP, 2D DP questions. These are memorizations. Done. Fourth and the final question now. What is my fourth question? Fourth question is minimum operations to equal binary string. Fourth question, minimum operations to equal binary string, to equalize binary string, to equalize binary string. Done. What does this question say? You are given a binary string s and integer k. In one operation, you must choose exactly k different indices and flip each 0 to 1 and each 1 to 0. Return minimum number of operations required to make all characters in string equal to 1. If it is not possible, return -1. Okay. I hope you guys are clear with the question. I'll explain it again. Now, so what are we going to do here? Anyone, guys? Anyone in the chat? How are we going to solve this question right now? Come on, guys, it's easy, not much difficult. We have to return minimum number of operations to make all strings equal to 1. If it's not possible, we have to return -1. I'll take one example. Let me take the first example given in explanation. Example, let it be 110 and k is equal to 1. In this case, there is only 10. So, my output is gonna be, what will be my output? My output is gonna be 2. Is it? Man, chat is not active today. My output is gonna be 1. Just 10, flip it. Now, if it is, I'll take one more -1 wala case example. which is let me take string as equal to 101 and let me take k is equal to 8. So in this case my output is equal to -1. I'll take one more example. What was here? I'll take a different example other than that is given here. So let me think of anyone in the chat. Give me a anyone in the chat. If you are ready to give me, give it to me. Give me a whatever the string. No. Let me take an example. Example s is equal to 00110. K is equal to 2. It's a binary string. Did I miss it previously? I hope no. Yep, it's a binary string. So k is equal to 2 I have took. Now I'll take what we will do here. We'll take the length of string. Length of string is equal to 5. Count is count of 0 count equal to 3. Now I'll take one more, which is number of ones. That is, I'll take it as w equal to n minus n is length, 0 count is, let it be 0 count, okay, let it be z equal to z, let it be z, n minus z, which equal to 5 minus 3 equal to 2. Now, so we need to flip 3 zeros, right? This is not a trivial case. So what we'll do, we'll move to the general case. First we'll check m is equal to 1 and then m is equal to 2 and then m is equal to 3 and m is equal to 4, m is equal to 5. M is equal to 5, it is not possible. For all the flips, it is not possible. Okay. First what I'll do, I'll check for m is equal to 1 to 5. For all the cases, it won't be possible. What will happen? M is equal to, at m is equal to 1, m into k is equal to 2. But we need minimum 3 flips. Fails. So this fails. M is equal to 2. Now 2 into 2 is equal to 4. 1 extra. Now 4 minus 3 equal to 1. Extra flip. 1 is odd. If it's odd, again it won't work. M is equal to 3. Again, thus 3 will be the difference. Difference will be 3 here, odd. So it won't work. M is equal to 4. Difference will be 5. Again odd. It won't work. M is equal to 5. Again the difference is equal to 7. Odd. It won't work. So answer is equal to, answer will be, as they have said, return -1. So answer is equal to -1. Basically, I hope I have explained the question very carefully, very clearly. Now I'll quickly go to what? My intuition. Intuition. Simple intuition. Binary string given. string given, make it to make all ones. By flipping k bits at once. So here there will be some this is the only thing. Now going on to the next one, observation. I'll take it as key observation. What is it? We'll be flipping k bits every now key observation 1, every operation flip k bits. So total flip, total number of flip zeros should add up to total zeros. Done. Now after, since we are flipping k bits, it can be flipped back also. Can be flipped back. Okay. Now and also minimum operations equal to should be found such that first one what? Flip 0 total is equal to z, and the next one is remaining flip m into k minus z must be even. Must be even. Done. Next point. Now final one, what is it? Depending upon m is odd or even, we'll put different parity conditions. Different parity conditions applied for balancing string. Balancing string to all ones. Done. Quickly going on to the approach. First step, we'll count. What are we gonna count? Zeros and ones. Z will take as 0, count 0, and W n minus z, count 1. Done. Now, second one, trivial case. Trivial case. What is trivial case? If z is equal to 0, which means all ones already earlier itself, then return 0 if, then one more, if k equal to 0 can't flip anything. Is it given in the constraints? Let me see what is k value they have given. Okay, this condition we can apply or we can't because k is already greater than, but for safety I am applying. In this case, return -1. Now the next case, next trivial case, first one, second one, third one. If k is equal to n, this means if all zeros one flip makes all ones, otherwise or else impossible. When impossible, what we should do? We have to return -1. Done. So now I'll move on to my third step for general case. Done. For general case, what I'll do, I'll iterate over the possible number of operations. First, iterate over possible number of operations, then that is m, then for each m what I'll do, each m I'll check. What should I check? M into k greater than or equal to z. This is at least z flips, at least z flips needed to cover all zeros. Done. I'll write it neatly again. M into k greater than or equal to z. Now the next step, m into k minus z must be even. This is to cancel extra flips. Done. Now final condition. Within this case, the final condition, not the overall. If m is, okay, just give me a second. If m is odd, we have to ensure m into n minus k is greater than or equal to n minus z. Okay, so with this, finally what I'll do, I'll return the first valid m. And in my fourth and the final step, what I'll do, if no path exists, if no valid exists, valid m, I'll return -1. That's all is this question. Now, what should I do for this question? As I said, I'm not gonna give any pseudo codes. But I'll definitely give you the time complexity and the space complexity. This is a little bit similar to, there is one Leetcode question. I don't know how many of you are aware. I'll come to that later. I came across this recently, a similar kind of question. Now going on to my time complexity. Now, what is this first? Iterate over m from 1 to n. Now, each iteration takes O of 1. So worst case, what is my worst case? O of n. So my time complexity is equal to O of n. Done. Now going on to the space complexity. I'll give the pseudocodes for this as well as the third question. Fine. Now, space complexity is very few integers we are storing, like z, w, n. So it will be O of 1. The final space complexity is equal to order of 1. Done. Now pseudocode. I'll write it quickly. Okay, class solution define function n is equal to length of s, then take z, then take w, initialize them 0, non-zero, and then are three special cases, trivial cases. I have explained what are they. So first, case 1, and next if condition. Now if case 1, what should I return? Return 0. If case 2, return -1. Case 1 is all are already 1, all ones. This is k equal to 0. And now case 3. If case 3, if here z equal to n, means I'll return 1, else -1. Return 1 or -1 based on this condition. What? If z equal to n, 1, else -1. Done. Now what I'll do, I'll run my loop. After this is done, run my loop for m in range (1, n plus 1). I'll put on my formulas which is first one, if m into k lesser than z. Sorry, if m into k is smaller than z, this is my invalid case. So here I'll simply continue. Now I'll put my first formula. If m into k minus z and 1, in this case I'll put it equal to 1. If this is equal to 1, again I'll continue it. Now the third and the final condition, if m divided by 2 is equal to 2. Okay, so if m divided by, this is modular division, modulus. So if it is even, basically nothing but even, modulus m modulo 2 is equal to 2 is equal to 0, which is even. In this case I'll put one more if condition. What is that? If m into k minus z, sorry guys, if m into n minus k greater than or equal to z, what I'll do, I'll return my m value. Else what I'll do, there is one more if condition here. If m into n minus k greater than or equal to n minus z, in this case also I'll return m. Then finally return minus 1. This is my pseudocode. That's all. Now pseudocode for third question. I'll quickly go robot path counting, which is a robo path count. Actually, the second question is more tricky than even the fourth and the third question today. I personally felt. Again, depends to person to person. Now, quickly going on. DP2D, you all know how to put initialize. Class solution. Define a function, whatever it is. And then we'll take mod value. Mod is equal to 10 raised to 9 plus 7. Then take mn, then lru cache, now I'll take one more function within this. I'll define one more function. I'll take all this moving right down and all, ni nj, thus I'll take is equal to, this function will have what, I int j int direction int, and then optional, this is tuple or tuple, whatever you guys call. I mean, if you want me to write, I'll just write it. Let me just write that also. Int optional tuple int comma int. There's my function. I'll just move the screen a bit this side. Now what I'll do, I'll take ni nj is equal to I comma j plus 1 if direction equal to 0, else I plus 1 comma j. Now I'll put a while loop or while condition while n I is lesser than m and greater than 0, and nj is also same, but for n this is ni, and now nj for n. And again, what is the other condition? Grid of ni nj is equal to 1. This is for the reflection of mirror. After this, I'll put a if direction is equal to 0. This is moving right, that is reflect to down. Ni, increment ni, then direction is equal to 1, else nj, increment nj, direction is equal to 0. Now if 0 smaller than or equal to ni less than m and 0 lesser than or equal to nj less than n, what I'll return? I'll return ni comma nj and return none if out of bound. This is return none out of bound. This is out of bound. Out of bound. This is for out of bound. Now I'll put my dp table, where here I'll put my dp table. How will I construct my dp? dp is equal to 0 into n for underscore or for I in range, whatever, in range of what? In range of m. dp is equal dp of 0 0 is equal to 1. This is the starting point. Now I'll iterate over this dp basically. For I in range m, for j in range n. Next, what should I do? Checking grid condition. If grid ij equal to 1, I'll skipping the mirrors. What I'll do, I'll continue. Now I'll put as base is equal to 0. Okay, sorry. Base is equal to dp of ij. This is my possible base. Okay, this is j. Now if base equal to 0, that means no path to cell. I'll continue this. Now I'll put one more loop for direction dir in 0 comma 1. This is for trying both the directions. I'll take one more, next is equal to next endpoint of I comma j comma direction. Now I'll take a if condition. If nxt is not found, If not found, what I'll do, ni nj is equal to nxt, and then I'll call my dp table again, the 2d dp of ni nj is equal to dp of ni nj plus base modulus of mod, which is 10 power 9 plus 7. Now finally what I have to return? Finally I'll be return dp of m minus 1 and n minus 1. This is my answer. This is my bottom right dp. This is my answer. Pseudocode for third one is also given. I hope everyone are clear with it. With this, I'm gonna end today's live stream. Thanks everyone who joined. Please like, share and subscribe to the channel. Please share, subscribe. Tomorrow morning we'll be back with another new live stream. So yeah, we'll meet you. Until then, have a nice day. Have a good night. Sleep well, enjoy. And we'll meet with a brand new live stream tomorrow morning with Leetcode, next Leetcode weekly contest. Like, share and subscribe to the YouTube channel. With this, we'll end today's live stream. Thanks everyone whoever joined.